Okay, so a couple things we're going to do today. First of all, I want to kind of wrap up the talk or the lesson on surface area of a cone and the surface area and the volume of a cone, surface area, and volume of a sphere. Okay, so we did the surface area, the volume of a cone on Tuesday. All right, so I want to give you an example of that. Now, underneath the lesson plans there, Ms. Knudsen has some formula sheets for you. So each of you should have a formula sheet. You can fill in the formulas for areas of the two-dimensional shapes. I gave you all the three-dimensional shapes. All right, so you can use that. It's cleaner. You can write some things on there as far as what each little letter variable represents. You can draw a couple pictures, but no examples or anything like that. Okay, so you should have some formula sheets given to you that you'll be able to use. All right, here's what we want to do. So in our packets, all right, we're going to look at this problem here, or we're going to investigate. Let's see, it should be on 81, I think it is. All right, so if you'll get your packet out and look at page 81. There we go, page 81. There is a part D at the very bottom of the page, and that's what we want. So hopefully we can get somebody in class to read that portion for us, and after they read, we'll pause the video, and then after they're done reading it, we'll go through it. Okay, so you should have drawn a couple things here. So we have a cylinder, okay, we have a hemisphere, and we have a cone, all right, and the radius is R. Let me draw this a little better here. There we go. So the radius is R, and the radius is R, and the height is R for the cone, and for the cylinder, and for the sphere, of course, it's R all the way around. All right, so D1 wants you to rank the volumes. All right, figure out which one's largest. Okay, so again, we're going to pause the video, take a minute, figure out which one's largest. Okay, hopefully you figured out. Goes largest, medium, small. Okay, so we went ahead and ranked the volumes. All right, number 2. Okay, so what we want to do on number 2 is express the volumes of the cylinder in terms of R. So a cylinder, okay, has a volume of pi r squared times h. Okay, the cone has a volume of pi r squared times h divided by 3. All right, that's our formula that we came up with on Tuesday. Okay. Then we're going to simplify these down a little bit more before we move on to part 3. So let's simplify this a little bit more. Pi r squared, the height is r, pi r cubed. Here we have pi r squared times r over 3, which becomes pi r cubed over 3. So let's take a look at question 3 on the next page. Wants us to make a conjecture about the formula for the volume of a hemisphere. So look what these things have in common. All right, we have here and we have here. What exactly do they both have in common? Hopefully you said they have a pi r cubed in common. All right, we got that, pi r cubed. All right, but obviously that's not the sphere, because we said the sphere was not the same as a cylinder, that it's smaller. So there must be something different there. Well, let's look at this. This one's divided by 3. Okay, but we can do that with this and just simply put a 3 and a 3 there. And it comes out to be the same for the cylinder, right? So now, not only is a pi r cubed the same, but they're both divided by 3. So now it's starting to look the same. But yet, we know the cone is smaller than this. So they're not, the hemisphere and the cone aren't going to have the same volume. So we still got a little more work to do with the hemisphere. All right, well, we've got 3 here. We got 1/3 there. We said the hemisphere was in the middle. So what number must be on the top? Hopefully you said 2. Okay, now that makes sense. So now we got 3, 2, 1. Everything else is the same. The problem is that's a hemisphere. So obviously we're going to have to double that. And there's our formula for the volume of a sphere. In your formula sheet, you'll see that that's there. Okay, so volume of a sphere is there. All right. Also, surface area is there. Okay, surface area is 4 pi r squared. All right. So we are done with all of our shapes. We have spheres and we've got cones. So on your formula sheet that should be handed out to you, okay, you should have those formulas. They're already there for you. You don't have to worry about it. But let's do a couple of examples, okay? Let's do the cone first. We remember that we had that volume, we had that cone, ice cream cone from Cold Stone, right? And it was just huge cone, right? So we had that, okay? And let me see, I think, if I remember right, that cone, let's see if I can find it, there it is, 8 and 22. So it was 8 this way, and the height was 22. All right, so we need to find the volume, how much ice cream we can put in there, not even counting the ice cream that's going to roll over the top, right? Because it's an open cone, we might have 2 scoops or 1 scoop or whatever. But let's just find the volume that we can fit inside there. So we have volume equals, here's my formula, pi r squared h divided by 3. So volume equals pi, we know. Radius, well, that's 8. Height, that's 22. We're going to divide that by 3. So take your calculator, put that in. So I'm going to go pi times 8 squared times 22 divided by 3 equals 1474, I believe it was. Yep, 1474. Okay, that's my volume. Now if you go back and look at that surface area of that cone, let's go back here a little bit. Okay, the surface area was 588.1. Wow, so the volume is this, and the surface area was 588. So that, if we take the surface area divided by the volume, it's going to be a pretty small ratio. It's going to be way less than 1. So, as we've said, that the shapes are getting a little bit more efficient. So a teepee type shape or a cone type shape for a house is going to be pretty darn efficient. All right, because you have a lot of volume, not much surface area. So something to think about when you start to design your house today, hopefully. All right, pause this whenever you need to. That's how you find the volume of a cone. It's pretty straightforward, though. You just punch the numbers in. For a sphere, what you're going to do on your test is I'm going to give you a ball, all right? And you're going to have to find the surface area and the volume of the ball. All right, so I have a basketball, and I'm going to find the surface area and volume of that. Okay, so here's my orange wore-out basketball that many of you have seen. Okay, to do this, I'm going to take a soft measuring tape, and we're going to measure around the widest point right there of that basketball. Right, we're going to measure around it. Okay. Well, we've done this a couple times today, so I'm just going to tell you that that circumference, which is what that is 30 inches. Okay? Had a couple people measure it today. That's what they came up with. How's that going to help us? Well, my surface area formula is this. and my volume formula is this, so I need a radius. And if I know what the circumference is, we can find the radius. So 2 pi r is equal to 30. So this is kind of what you're going to do on your test next week when we're going over this stuff. Okay, you're going to have to go measure a ball, soft measuring tape, go around it, find a circumference, okay? And then you're going to have to figure out what r is. When you do that, you probably know we're going to divide by 2 and by pi to isolate that variable. Thing is that you have to make sure that when you divide, that you take 30 and you divide it by parentheses 2 and pi. If you divide it by 2 and then divide it by pi, or 2 and then times it by pi, that's kind of what happens sometimes is students will put 30 divided by 2 pi. It will divide by 2, but it will multiply by pi, and you get the wrong answer. All right, so what you have to do is put parentheses around the 2 and the pi because you're dividing by both things. So let's do that. So we're going to go 30 divided by parentheses 2 and pi, close with a parentheses. I'm going to go equals. See, even this calculator just did it wrong. I'm going to try it again. 30, oops, clear it out. 30 divided by parentheses 2 times pi, close with a parenthesis, press equals, and we get it right. So r is equal to about 4.78, rounded. Okay, there it is, 4.78. Now that we know what the radius is, we can find those surface area and the volume because they're all in terms of the radius. Okay. There we go. So surface area, 4 pi r squared. Volume, 4 pi r cubed divided by 3. So we put that in there, figure out what the answer is. So let's see, we're going to go 4 times pi times 4.78 squared equals 287. I guess that's okay. 287.7. Let's figure out the volume now. So clear that out. 4 times pi times 4.78 cubed, okay, equals, and I'm going to divide that by 3. 459. So again, 459.8. Notice we get a lot of volume for the amount of surface area. Okay, so another very efficient shape. So when you're thinking about designing your off-the-grid house, remember that, you know, these two shapes are giving you a very efficient, and that's what you're getting graded on, okay, is efficiency. So today, here's what's going to happen, all right? First of all, in our packet, on page 83 is where we're going to start at, and I know it's upside down, okay? Try to get over that. 5.2, 5.4, and 5.6. We're going to do 5.3 as a class on Monday. All right. If you have any more questions on any of these assignment questions, we'll deal with it on Monday. Okay. Monday we're going to wrap up all this stuff. I want to get this assignment done Monday, and then probably do a couple more things with surface area and volume and everything and be done. Tuesday we'll do another little activity to wrap it up, and then Thursday will be our test for next week. Okay. Anyhow, so that's what we want you to do. After this, you're gonna go down into the lab. Okay. you got to do a couple things. First of all, I put a rubric in the classroom for you, Google Classroom. You'll see that it is, I think it's called Rubric 4 Off-Grid House, something like that. You can look at it and see how you're going to get graded. Okay? That's number one. Number two, you need to research how many kilowatt hours, okay, you're going to use for your house. Now, when you find kilowatt hours on the project paper, if you don't have one, we've got some extras for you. You can use those. Okay. On the paper, though, I'm going to pull it out here so I can look at it myself. Where's that? Coming up here. Hang on. I'm getting there. Okay, so here it is. All right. Talks about how the average house in the U.S. uses 900 kilowatt hours per month. All right, so what you want to do is go to this website that I put down here at the bottom of that page, or you can go to my web page, which I think a website, I guess, whatever, and I believe that it's on there. Okay, I'll double check, but I think if you go to Geometry Unit 10, let me take a quick look here and see if I put that on here. I think I did. I'm checking on that right now. Okay, let's check and see if it's underneath Unit 10 or if it's just under Geometry. There it is. It's under Unit 10, Project Link for Energy. It will take you there. So if you go to my website, go to Unit 10, Project Link for it'll take you there. All right, so here it is. So what you want to do is figure out, okay, like you can't see it obviously, but you will when you get there. You want to figure out, are you going to have a kitchen? And in your kitchen, you're going to have a refrigerator, you're going to have a freezer, you're going to have a dish. Well, what are you going to have? And that's going to tell you how many kilowatt hours that is. All right. And then you got to figure out your well pump. So, because you just can't, you go down to the lake and drink water. It ain't going to work that way because you have to have it sanitized. So if you have a well pump, obviously it's going to be good water. Okay. And then entertainment all the way through and other household equipment. Okay. You got to have heat. All right. You got to have a place where you're going to heat water. I mean, there's certain things you have to have. Okay. You can't, for instance, go wash your clothes in a river. Okay, that's not environmentally good. And you're making an off-the-grid house. You're not going to sacrifice the environment for that. All right, heating, so forth. Once you figure out what your average kilowatt hour is, okay, then what we want to do is print that. And I think if you do a right-click, it'll allow you to print. Okay, or you can somehow, I don't know, maybe take a picture of it or a couple of things. Anyway, it'd be better probably if you printed it. All right, and I need to have that document. So when you turn your project in, you're going to turn this document in that has all your kilowatt hours. Okay, so that way I know that you actually figured something out. All right, so go to that website, figure that out. Okay, and second, then you need to figure out where you're going to put the place, right? So I said you could go in the northwest. All right, you could branch it out a little bit if you wanted to. Okay, but you need to run it by me before you turn it in, just so we know where you're going to put it. So find a location for it. If you're going to do solar panels, you got to find a location that's going to give you enough sunlight. Okay, so you're going to have to look that up. Hey, maybe I want to put my place in, someplace like maybe I say, okay, I'll put it in Olympic Peninsula or something like that. All right, if you put it over there, you got to make sure that you're going to get enough sunlight. Okay, there's some places that might not get that. If you're going to do wind turbines, you're going to have to figure out, all right, how much kilowatt hours do I get from my wind turbines? How much are they going to generate? And I have to go to a place where it's obviously going to be a little bit windy. So all this stuff you've got to figure out. Plus, you're going to have to figure out how many solar panels you're going to use. You just look at all that stuff up, okay? Research it, find it. It's all there. All right? You just have to be relentless in finding those searches and looking for that information, okay? You can rely on each other a little bit. Remember, you can work together on this, right? Everybody has to have their own write-up, though. So if you're going to work together on this, then I need 2 or 3, however many people are working together, of the online usage things. I need 3 of your stuff that you're every write-up. Okay, you have to have, everybody has to turn in their own thing. Make sure we have 3 copies of stuff, or 2 copies if you're working together as a pair. All right, that's what you should be doing. Okay, when you get all that done, you need to figure out your materials, what you're going to make it of. Okay, you can't just say I'm going to build it inside of a mountain and that's how I'm going to make it live in dirt. Again, that's not going to work. Okay, you're going to have to figure out some materials. You can't just dig in a hole into a mountain and live like a mole or something like that, right? You got to have something that you're going to enclose it with, all right? Figure out what those materials are going to be. Figure how much it's going to cost. Research it. Look it up. How much does it cost? How much does it cost? Okay, you've got that $25,000 limit too. So when you start putting all this stuff together, it's going to take a little bit of time. That's why you get today to do it. So there's your assignment to work on. Okay, get into the lab. Don't waste any time. Work on that stuff and get it done. I'm giving strict instructions for Ms. Knudsen to go around, and she's going to check off. All right, she's going to give me who has gotten through and did these things, right? Did the CPI, did the online usage calculator for kilowatt hours. She's going to check you off, make sure you got that. You can show her the printout. Hey, this is mine, okay? She's going to make sure that you have started a design. She's going to make sure that you have started to figure out your solar panels, how many solar panels you're going to need, all right? She's going to be looking for that stuff. That's part of what you're getting graded on, is by meeting a timeline here and getting this part done. Okay, so she's going to be looking around, checking that stuff off. You didn't get that today? Then she's going to let me know, okay? All right. Hey, I'm going to quit talking and let you get working. All right, so if you have any questions, I'll be back this afternoon. You can pop in and see me. All right, that's it. Bye. Stop.